Good afternoon, good evening. Welcome to Codit Live. I'm your host for the day, Sam Basu, and with me I have my good friend, Jay. How are you, sir?
Hey, good, Sam. How are you? Nice to be streaming with you.
Yeah. At least we get to hang out on the internet. It's been a long 2 years, but I did actually see Jay about a month or so back, and it was so good to be with friends in person for tech conferences starting to come back. But yeah, we are here. This is a different type of stream. This is not a regular coding stream where none of my code compiles and you all laugh at me. This is a user group meeting. It's a little bit more formal because we have a good speaker here who knows their stuff as compared to me who cannot code. But we're going to have a little fun. This is, well, actually, let's get us, screen sharing going. So Jay is the speaker. I'm the annoying sidekick, so I'm going to set things up a little bit before we start. This is a user group meetup. So let's see if I can share my screen. There you go. All right. So yeah, welcome people. This is a user group, and if you're looking for any of these older names, you're not going to find them. And Jay, I don't know if I ever told you the history. This user group started about 2009-ish timeframe. We went all out with Windows Phone for a few years. Then we said, no, let's make it generic enough. Let's call it the Windows user group. And then we started getting a lot more JavaScript and a lot more mobile stuff. And then we said, okay, let's just call it app dev. And then it was generic enough. It's Columbus. We are, based out of Columbus, Ohio. And then the pandemic happened and everything is virtual. Like, okay, let's just call it global. And it doesn't get unless we go to Mars, I think we are okay with the name here. So we are the Global App Dev User Group. If you don't know about us, tell your friends. We have a website. We are on Meetup. We are on Twitter, and we meet right here on Twitch, third Mondays everywhere. And for those of you who are maybe regulars, you know that we do like an hour or so of the speaker sharing his or her knowledge, and then we kind of hang out a little bit on Teams. If you want to turn on your cameras and just chit chat, that's fine too. If you don't, so one thing I do miss, Jay, is pizza for user groups, but some nights we try to do pizza as a family. It doesn't work out every time. All right, so we do have some sponsors who, get us going. Microsoft supports us and Progress supports us. We do actually partner with Visual Studio Live folks, which I'll mention in just a minute, what they have coming up. We do have a sister user group. This is the Columbus .NET user group, also called Condig. And they meet the fourth Thursday of each month. And, some months it ends up being the same week, not this time around. So it looks like they're meeting June 30th, so which is actually 10 days apart. Oh, wow. Fourth Thursday is like literally the last day of the month, pretty much in June. So they have, what are they talking about? TDD. And in this screenshot, I don't have the speaker name here. But if you're into test-driven development or just want to get a refresher, go and join them. I think they try to host in person and then also stream it out on Twitch like we do. All right, and we talk about a few, regional conferences, some bigger ones coming up and that are close by. And I think my good friend Jay here might have something to do with this one here. So Jay, do you want to talk about this?
Yeah, sure. For those in the Midwest, especially, but of course anyone's welcome. We have Beer City Code here in Grand Rapids, Michigan, home of the microbrewery capital of the U.S. So if you like beer or code, we'd love to see you. Or if you like both, then it seems like a match made in heaven. So that's Saturday, August 6th. In the past, we've done a 2-day event, but this year we're kind of keeping it simple post-pandemic. So it's just a 1-day, Saturday, all day long event. And if you buy the VIP ticket, you can go to a brewery afterwards with the other speakers and organizers of the event. So it should be fun. Yeah. Lots of good people coming to speak there.
Yeah, and I can vouch for that. I've been there multiple times. I was very sad this year. I have a conflict, so I cannot make it, but it's an amazing event. So if you're anywhere close, and you can drive up, it's great. All right, a few more things coming up. KCDC, this is coming up right around maybe the same time, maybe a little after actually, August 8th to 10th. This is in Kansas City, not Kansas, it's in Missouri. But this is, a great conference, 2 to 3 days, lots of speakers from all around the world. And right after that, so August is going to be busy, Jay. Baby steps, but a lot of conferences are coming back, which is so nice to see.
Yeah.
We have Codepalooza. This is Chad Green and the team. This is in Louisville, Kentucky. Another 3 days, one workshop day and 2 days of conference. So, a lot of good stuff coming back in the Midwest. Now, we do partner with Visual Studio Live. They, put together big conferences all throughout the country. They're slowly also coming back with some conference as well. We just had one in Austin. And then the next one that's coming up, this is, look at that. It's also in August. So August is really busy. This is Microsoft headquarters over in Redmond, and they have Visual Studio Redmond coming up in August as well. And if you do go to the VS Live shows, you get a discount as a user group member. All right. Without further ado, Jay, welcome back again. I'm going to let you introduce yourself, but I've known Jay for years. Just an all-around swell and amazing guy, and really passionate about what you do. So, Jay, we're glad to have you, and the floor is yours.
Thank you, Sam. Yeah, I appreciate it. Yeah, go ahead.
I'm just going to give you your desktop back and be your sidekick who just asks you questions all along.
Sounds perfect. Thanks for the introduction, and those are all some really great events. Actually, I'm going to be at all of those events except for the last one because it overlaps with KCDC, but we'll be at VS Live in I think it's in November in Orlando.
Oh, nice. Very nice.
You were also basically showing me slides that was reminding me what my schedule this summer and fall looks. Probably yours too, I imagine.
Yes. But it's all good. Yeah, glad to do the things we do.
Well, welcome everybody. As Sam said, my name is Jay Tower. Jay is short for Jonathan. We're going to talk tonight about not how to avoid building something called a distributed monolith, which is basically what happens if you do microservices wrong. So that's going to be what we're talking about this evening. To start out, I want to tell you a little bit of a story here. So recently a client came to us at Trailhead, the company that I own, software consulting company that I own called Trailhead. They had an application that was just about ready to launch, or so they said. And they had built this application using microservices, or so they said. And, they just, according to them, had a few performance problems, maybe some entity framework queries that needed to be tweaked, and maybe a few other performance things that they needed our help with to, just really get it over the finish line strong. When we signed all the contracts and started looking at that code of theirs and their architecture, we saw really in just a few minutes that it was going to take a lot more than just some minor tweaks or architectural improvements. Is going to be more of a complete re-architecting of their application to get it to perform the way they wanted. They had kind of undersold the problems that they were experiencing, because instead of the microservices that they had meant to build, they had instead built something called a distributed monolith. So we're going to talk a little bit tonight about what that means, how they got there. I want to actually tell you some of the most common things that I've seen working with clients and others doing microservices architecture myself. Some of the most common pitfalls that I've seen people fall into that causes them to take what they intended to be microservices and accidentally to build this thing called a distributed monolith. So, of course, we'll start by talking about what that is, and we'll talk about, of course, what microservices are and the differences between them. And then I'm going to take you through these 13 common pitfalls.
Yeah, I was going to kind of have you start there because I have some misconceptions, as I'm sure a lot of people do. And, while you're getting started, chat room, please feel free to chime in, keep this interactive, ask Jay any questions you might have, and we'll try our best to answer.
Yeah, thanks for the reminder, Sam, about that. So if anybody has questions, Sam's going to just kind of interrupt me and call them out, which makes it a little more interactive, even though we're doing streaming. here. I think that would be more fun and useful for you. So please feel free to type those in at any point, and Sam will relay them to me. So again, my name is Jonathan Tower. My friends call me Jay. I'm a now 7-time recipient of the Microsoft MVP Award in .NET. Also one of the founding partners at Trailhead Technology Partners. We help our clients build microservices with their projects, and also architect, build lots of other kinds of technologies as well. So over the past about 24 years of my professional experience, I've either seen or made just about every architectural mistake that can be made. So today I want to share some of those experiences with you all, and specifically as it relates to some of those mistakes with microservices. So first of all, something I like to do at all of my talks, whether it's streaming online or in person, or at a user group or whatever, I do these talks as kind of a way to just give back in the community. There's been a lot of people who've invested in my career or my life over the years, and as a way to kind of pay that forward, I do these talks. Obviously Sam does the same thing, and we don't really get paid for that per se. And so it's something that it's more of just a community good. But in a large sense, all of us here in the software community are very lucky that, we're fairly well employed. Many of us have some disposable income, maybe even a lot of disposable income, and a lot more options than about 1 billion people in the world who don't have access to clean water. So that's kind of an issue that's close to my heart. And this charity called Charity Water is one that I like to work with and give some of my money to help bring clean water to those parts of the world, help eliminate some of the issues that come out of dirty water, like obviously sanitation, health issues, poverty. All these things are kind of interconnected with each other. So while I'm talking, if you hear anything useful, interesting, oops, that was supposed to say $100. So if you guys give $100 during this talk today by going to this bit.ly link, which is Global App Dev User Group, or GADUG-water. So that's bit.ly/GADUG-water. If you go during the talk and you all donate $100, I'll match that with $100 of my own. All right, so
it's very nice of you, though, Jay. And I did highlight the URL if anyone wants to,
awesome. Yes, thank you for sharing that, because I will come back to it a couple of times, but sometimes things move so fast, people don't quite get a chance to type it in time. All right, so like Sam said, what's a monolith? What's a distributed monolith? What's a microservice? That's kind of our starting point here, so we're all on the same page. So let's start with what a monolith is. So the monolithic architecture, it's kind of the traditional unified model for the design of software programs. Typically, the components in a monolith are interconnected or interdependent rather than being completely loosely coupled. And each component would have to be present in order for the entire application to be compiled or executed. And typically then all of those components would be deployed together as a single application. So that's kind of the concept of a monolith. Think of it as like inseparable, one big piece, one big application that has to be updated together, deployed together. There's advantages and disadvantages to the monolith. It's actually a lot easier to build a monolith than it is to build a microservice. So that's kind of one significant advantage. They usually have better data throughput. Not necessarily scalability is better. So maybe that sounds like I'm splitting hairs on some performance terminology there, but we'll talk about that more as we're going here. Monoliths are scalable through a bunch of different technologies that have existed for a long time. Things like load balancing or data sharding. We'll talk about those tonight. There's fewer cross-cutting concerns. So if you're doing things like logging, it's a lot easier to do that in a monolithic application than it is in a microservice. And maybe the most important advantage of a monolith is something called immediate consistency. And we'll talk about that a little bit more in detail tonight too. Of course, there's disadvantages to a monolith. You have to, even if you're making a small change, like just a text change or something like that, you probably have to update the whole application. We've all probably done that before, where we create an app and you deploy. You have to, do some like button name that's different or something. You have to deploy the whole app just to get that change to go live. Disadvantage, typically they're more tightly coupled, so it's easier even for a well-designed monolith for one error to break lots of things in the application. Typically, a monolith has to be built with the same technology, at least on each tier of the application, or each layer of the application has to be built with the same technology. Makes it a little bit less agile than microservices, and doesn't allow for what I would call small focused teams to be working on just one little part of the application. So we're going to talk about all of those in more detail, but that just kind of gets us all on the same page about what a monolith is versus what we're going to talk about, which is microservices.
Hey, Jay, before we move on, I have to ask you this, because I remember this picture here. This was in Utah, or where was this, and what was it?
Yeah, the story behind this photo is that some sort of an art installation in it's actually Utah, just outside of Moab, Utah. There's actually a couple of different national parks. This is in one of those two national parks. And just kind of in the middle of nowhere, a long way from anything, some hikers discovered this monolithic metal thing buried into the ground in the rock. And, it was kind of like, did aliens put it there? No, of course. It was some artist, but nobody knows for sure who did it, actually. So they called it the Monolith. So when I was Googling for free images to use, this came up right away.
It's the perfect monolith.
Yeah. Somebody lit it really cool for this photo too, so that makes it kind of fun. One thing I just want to outline too here, and we'll talk about this tonight, is that monoliths are sound like the bad guy when you're talking about microservices, which is a big buzzword right now. Everybody's talking about microservices, and the bad guy in all of those talks or all of those blogs, all of those things that talk about microservices, the bad guy is the monolith. That's the thing you don't want to do if you're trying to build microservices. I would make the argument that a monolith is a perfectly legitimate thing to build. It's just that when you try to build microservices, you end up building this other thing that we're going to talk about, a distributed monolith, which is not good. So this is kind of what an architecture of a typical monolith might look like. You have multiple clients connecting into probably like some sort of a middle tier application, like an API or something, with a database behind it. As I mentioned, you can scale these up. You could scale vertically by adding resources to the middle tier. You could add, memory or processor capability to that middle tier and make your application perform better. You could also scale up your database by doing the same thing, make it a beefier database server or virtual machine, and get more performance out of your application just by scaling it simply in that what they call vertical scaling technique. You can also scale these monoliths through some horizontal scaling, which would be things like load balancing, where you take the middle tier and you make multiple copies of it. The traffic then from the client is going to do kind of a round robin, first A, then B, then A, then B, and so on. And that gives you, almost double by adding just a one other server in a round robin like that. Gives you about double. If you add a third, it gives you triple, and so on. With just a small amount of overhead, you can add pretty significant scaling to your application. Now, that's only true if the database isn't your bottleneck. If the database is your bottleneck, then you probably want to scale your monolith in a different way, which is scaling it horizontally through something called data sharding, where you basically say all the data for this tenant or this client or this customer goes on this database, and all the data for this other one goes on this other database. And the application basically knows how to connect to both those databases, and it just connects to whichever one is correct for whoever's currently accessing it. That would be a pretty typical multi-tenant setup, and that would be a pretty typical way to do data sharding, which is a way that you can scale your application. That's a monolith. Okay, so that's monoliths, microservices. Sam, did you have a question?
Yeah, I was going to just mention something and see if you have similar experiences. So, and for the record, Jay and me are old men. we've been doing this for a while. I've built, a lot of monoliths in my days. But one of the things that kind of gets you is if you have, let's say, a middle tier or lots of, services or lots of APIs, or you have maybe a set of, web apps. If one portion of it is the one that's getting stressed, you kind of have to scale the whole thing up. And that's, you're paying a bigger price for scaling, and all of those things that you said work, but you're kind of having to scale the whole thing up instead of being able to isolate in just one API that you want to scale.
That's right. So the exception to that is your layers or your tiers to your application. But you're right, Sam, that if you have this situation here where you've basically got this monolithic middle tier application and that is your bottleneck, then, the login form code has to be copied to multiple web servers if it's an API. The order processing form, the cart management if it's an e-commerce site. All of the different parts of your application have to get copied to multiple servers, whether those are the bottleneck in your application or not. Let's say, login gets used 1 out of 100 times compared to other parts of your application. Well, you don't really need lots of copies of your login processing form endpoint. If, say, order processing or adding something to the cart, that endpoint is the one that's getting the vast majority of the action. That's the one you actually want to scale. So yeah, for sure, that's one of the downsides here is that you have to scale monolithically. You have to scale it all as a big single thing. Yep.
And in the chat room, King of Cod is asking, so what exactly is a microservice? And I see your slides, so go ahead.
Perfect timing. I'll have to slip him the 20 that I promised him for asking that question right at the perfect time, since my slide was coming up anyway. So microservices, basically splitting your application up into individual components that are sort of micro applications. Typically, you would think about this as APIs, as an API layer, and then a data layer being split up. So we'll look at an architectural diagram in just a second here. But compared to that monolith that we saw in the desert, these nice organized houses from San Francisco here that are called the Painted Ladies, I feel like this kind of visually represents what microservices might look like if they were buildings in the real world. Benefits of microservices, independently deploying each one of them completely separate from each other. Precision scalability, that's that thing, Sam, you were just mentioning, where if your add to cart endpoint is the one that's actually getting all the action, that cart part of your application maybe is its own microservice and can be scaled up completely separately from the login or the order processing or payment management or whatever account management parts of the application that might be split out into other services. High availability, you can actually update individual parts of your application without touching any of the other ones. Loosely coupled by definition, because you kind of treat these as completely separate things. You can you can treat them all completely separately, maintain them all completely separately without worrying about breaking something in one of the other ones. Analogy with these houses, if you imagine somebody flipping a breaker in one of these houses, the power's not going to go out in one of the other houses next door because they're loosely coupled. They're tied to the same power grid, but their power systems are separated from each other. Same thing if one of these is getting renovated, then it doesn't mean that you have to move someone out of all of the neighbors' houses. The renovation is just isolated to that one. So you can kind of think about that analogy when you're thinking about microservices. Obviously, because of that, it allows a more agile process with those small teams that are focused on just a specific part of the application that can make really fast incremental changes to that part of the application. There's disadvantages too, though. Microservices aren't perfect for everything. It does require a reorganization of your teams and your processes to match microservices. If your company or your organization isn't capable or interested in doing that kind of reorganization, I would argue that you probably shouldn't do microservices. Debugging and monitoring can be a lot more difficult. If you think about each of these houses being completely separate, like knowing what's going on in all of them or how something that happens in one affects something that happens in the other can be kind of difficult. It's really, really easy to do microservices wrong and actually accidentally end up with the bad guy of our story tonight, which is the distributed monolith. And so that's kind of a disadvantage. And then probably the biggest one that we'll talk about tonight is this concept called eventual consistency. If you try to avoid the concept of eventual consistency in your architecture for your microservice, chances are you're not actually building a microservice. So file that little term away, because we're going to talk about that a little bit tonight, eventual consistency. This is a typical architecture diagram for what a microservice might look like. This might be a helpful way to understand them. So you've got your clients accessing these different microservices, typically through API gateway. This API gateway is something that might kind of bring all of these services together under a single roof. Might make all the URLs more consistent. It might show or hide certain endpoints that one particular application needs or doesn't need. But then the important part of this is these columns kind of in the middle here, where you notice that there's an application tier and a separate database for each and every one of these services. And you also notice that there's no arrows directly between any of these services to each other, because that would create something we call coupling between them. And that would be basically unmicroservicing your microservices. So the way they actually communicate with each other is through the event bus. And an event bus is basically just like a message queue with publish and subscribe style to it. So each service can basically say, hey, this thing just happened where somebody changed this data. Maybe, for example, someone came in and changed their shipping address on their account, their default shipping address. And so the account microservice would publish an account change or an address change event to the event bus. And then other services that cared about that, like maybe the order service, would care about address changes, because when someone's going to do an order later, you want to have the new shipping address for them. So that order service might say, oh, I care about that. I subscribe to that event. Let me go ahead and update my own data. Now that automatically is where that eventual consistency comes from. So we end up with each service basically having its own copy of the data, which feels, from the DRY or the dry rule that we have had beaten into us for the last 30 years in software. Don't repeat yourself. It seems like really bad idea. It also feels like kind of an unnatural way to do database design, because you also learn in database design to normalize your database design and not have multiple copies of your data. But when you're doing microservices, you have to actually set some of those lessons you've learned about monoliths aside and actually break some of those rules to make it a good microservice. So that's kind of what a microservice might look like. And then that brings us to, Sam, go ahead.
Yeah, I was going to ask you a couple of questions. So one is from the chat room. If you can go back to the last one, though, and then I had a question as well. So King of God 231 is asking, wouldn't having multiple databases get really expensive? And I think you're kind of leaning towards that. Is there a cost factor to having your data replicated and maintaining multiple databases like this?
Yeah, I would basically say that if keeping things simple and small is your goal of your app, one of the major goals behind your application, a microservice is probably not the right choice. Basically, by design, microservices are complicated and big. So, even just look at this architectural diagram, right? Like each of these application tiers is probably a separate VM or app service or something like that. Each of these databases is separate thing that needs to be a resource that needs to be created in the cloud. You have to maintain an API gateway. You have to maintain an event bus. So even in the most simple architecture that you can come up with for microservices, it's way, way more complicated and way, way more resources, which means probably more expensive to set up than it would be to set this up as a monolith. So yes, basically it is more complicated and more expensive.
And see, you're so honest. Like you're obviously passionate about microservices, but you don't preach it to everything. It's not the solution to everything. There's a costs to be kept in mind.
And you should always be dubious of anyone that tells you that they've discovered an architecture that's perfect for every situation, right?
Yeah. And I had a question about the API gateway. Like every one of these, micro apps will have to publish something, right? That's their signature that tells the other parts of the app or the consumers like what your service or your API does. What is that most commonly in the form of? Is that a contract? Is that, kind of going back to, like a JSON type contract, or like even a what was the thing we used to use in the Windows world, like the SOAP-based thing that was so difficult?
Yeah, WSDL or something like that.
Yeah, Whistle, and then WCF, Windows Communication Framework.
Right.
Which was, one letter off from being something really bad, and it was very difficult, to change those contracts. So what is the thing with microservices?
Yeah, so the API gateway, the way you could think of it is it's a way to simplify and filter your endpoints, because you might have an endpoint that is, is very general, that is maybe used by multiple applications. If you have a mobile app and a web app, they might both use the same endpoint for authentication, or they might use the same one for, if it's a hotel chain, they might use the same one to like book a room at a hotel. And no matter what endpoint you're using, it's going to have a little bit different data in it. It's going to have different paths that you're going to use. And so the API gateway does a few things, but one of them is it brings that all together under one roof. So you could think of almost having like your mobile app could have one gateway set up that points to the different things that different microservices that are needed for the mobile app. The web app could have a different API gateway resource set up that points to the different endpoints for the web app. And then if you have things like authentication or multiple types of authentication options, if you do like OAuth plus you do like a login form using JWT, using cookies for some things, maybe the API gateways can kind of be a layer that abstracts that away from the microservices having to care about that as well. So there's a bunch of different things that they're used for, but it's pretty common to have them in a microservice architecture.
Got it.
Cool. Okay, so that brings us to the bad guy we were mentioning before, which is the distributed monolith. This is what you don't want to build. So what's a distributed monolith? This is basically what happens when you build highly coupled modules and then just try to distribute them separately. So you basically have built a monolith, but you've built it in such a way that you fooled yourself into thinking that it's microservices, and you try and deploy it differently, separately as separate applications that all rely on each other. There's a bunch of ways that this happens, 13 of them that I'm going to talk about tonight. This is actually the easiest thing to build when you set out to build microservices. If you don't stay very strict on yourself, this is what you'll end up with in some form or another. Maybe not quite as messy as this photo shows, but it'll be some form of a distributed monolith. The bad part about the distributed monolith is it's kind of the worst of both options. It's much harder to build than the monolith would have been. It'll perform worse than the monolith would have, and it'll be more difficult to maintain than either the monolith or the microservice would have been, and you won't get really any of the benefits that you want to when you're setting out to build microservices, like the separate ability to update services separately from each other, and all high availability and all of those things. So this is what we're trying to avoid building.
Jay, quick question before we move on. When you had, microservices that wrote out to the event bus, King of God was asking, like, it shouldn't it be like a two-way arrow as well? Because the other parts of your app might need to, read from the event bus, right?
Yeah, that's a good point. There should probably be an arrowhead on both sides of those. And I think what I was getting at is that they're just connected to each other. Because if you think about it, obviously these API service layer applications are also going to send data back to the clients as well. So it's probably all of these arrows are double-sided arrows technically.
And in the chat room, Furrer Wilson is saying it must be your lucky day because somebody was schooling them on monoliths versus microservices just earlier today. So yeah, you've come to the right place.
Perfect. Okay, so this is kind of what a distributed monolith might look like. I've got another option right after this slide too. This is commonly what they look like. The red arrows here are the problem arrows. So if you designed this, you could easily kind of glance at this code or glance at this architecture that someone else set up maybe, or even if you did it yourself and be quite proud of yourself because it looks a lot like the microservice architecture, right? Like, oh, look, I did it. But all these red arrows really are what's creating the problem here. If if services are calling each other directly, or if they're calling each other's databases directly like this is where the problems start to happen. We'll talk about why as we go through the 13 different areas. The other way that's very common, architectural diagram that's very common for my distributed monolith is this one, where somebody is maybe really used to building monoliths and they're really used to normalizing their database the way that you would for a typical monolithic application. And they just can't quite bring themselves to separate that data out and duplicate that data all over the place. And they find themselves saying like, well, wouldn't it be great if this is basically microservices? It's just that they're all connecting to the same database. And they don't even have to know that they're all connecting to the same database. So maybe it's okay. But what this actually does, and we'll talk about how in a few minutes, this actually couples these services together through the database and causes them to become a distributed monolith accidentally. So kind of summarizing those definitions, if you think about and then one other definition I want to throw out here, which is the ball of mud monolith versus the modular monolith. So if you think about kind of graphing these on a graph where we've got how physically separated the components are when they're deployed, monolithic down here and distributed up here, and then how logically distributed the services are from each other or the modules are from each other. So are they monolithic, like they're highly coupled to each other, or are they quite modular, like they've been written in a way where they're somewhat independent or completely independent from each other? So in the bottom left corner, you've got kind of the bad guy of monoliths, the ball of mud. We've probably all written these applications before where everything references everything else in the code. And if you go change one line of code somewhere, one place, you break 4 or 5 other places without even realizing it because everything is kind of, crisscrossing arrows of references between everything and everything else. Very difficult to maintain. Nobody likes this. And usually someone who has experience with this type of monolith is the one that ends up saying, oh, I don't like this. There must be a better way. Oh, microservices, let's do that. But then it's easy to fall into these traps that we're going to talk about tonight. Modular monolith is basically like a well-written monolith. This is the good guy monolith that we have been talking about some tonight. This is the one where you write it well, where things are still coupled, like the application has to compile all together and deploy all together. But you've got pretty separate services that are written and architected in a pretty great way where you can make changes to one part of the application without worrying that you break a different part of the application. Other than a few shared components, like say logging, for example, you don't have to worry about lots and lots of arrows between the different components in your application, that they're a little bit more siloed. So that's a modular monolith. If you go up here to the top right corner, this is, the holy grail that we're shooting for. This is that totally modular, completely separated from each other services that are then deployed completely separately. And then the most common thing to do accidentally when you're trying to do that is this distributed monolith, where you write it with lots of coupling between the services, but then you try to deploy it separately and you end up with this distributed monolith. So hopefully that helps summarize a little bit of what the options are and how you can get into these different situations. Which brings us to the 13 most common mistakes that I've seen that cause you to accidentally create a monster. The first one is actually just assuming that microservices are always better. I've kind of alluded to this already tonight, But Sam Newman, who's one of the lead thinkers when it comes to microservices, has this quote that he says, if you're going to build microservices, you should have, quote, a really good reason for doing it. Basically, if you come into it not kind of understanding the pros and cons that you're learning tonight from me, so hopefully none of you will be in this category after tonight, but a lot of people come into microservice just having read some of the, the hype about them. And I think, oh yeah, microservices are always better than monoliths, so I'm going to start doing everything as a microservice, not really knowing what the trade-offs are, what they're getting into. Sam Newman says, if you're going to do microservices, have a really good reason. Microservices are not inherently better than monoliths. There's different types of applications that are different fits for each. And microservices are extremely hard to do. We already kind of talked about resource-wise that they're more complicated, more expensive, but they're also more time-consuming to build than a monolith typically would be. So keep in mind that you're going down a path that's harder, easy to make mistakes that cause you to fail, and not inherently better for every type of project. So that's why Sam Newman says you should have a really good reason for doing a microservice. Some good reasons for building a microservice: if you're trying to reduce downtime, speed up your deployments, to isolate some data in one part of your application from a different part of your application or business. Just as an example, with a gRPC and the right to be forgotten, you might have part of your data that has identifiable information about users, and then other parts of your data are using abstracted versions of that user, where if you can separate those out into different data stores from each other, it would actually be a lot easier to clean up that user, to have them be forgotten if they're only in that one place. And then the other one is having separate teams that are working very independently from each other, with their own release cycles, with their own backlogs, with their own actually technology stacks even, that are each focused on different business area or service within your larger application. Those are some good reasons to build a microservice. Number 2 most common mistake is sharing data stores or data models. So this comes back to this diagram where someone who built a monolith in the past says, hey, why don't we just put all the data together into a single database? If you share your data store, like for this, let's assume this is a relational database management system, then anytime you change the schema of one service, you end up impacting another. So the services are therefore tightly coupled to each other. So if I try and change this one, I potentially might break another one that uses that same database table without me being aware of it. So I might accidentally break this one, which basically means that unintentionally I have created a coupling between these. Now, this often brings up a question: what if you use the same database, but you have everything in a different namespace, or depends on what database technology you're using, within a different schema from each other, so that everything is kind of separate, but they're all hosted on one piece of hardware? That's kind of okay. I would say as like an interim solution, that's kind of okay. But again, we're actually coupling those services together to each other in a performance way, because now if this first service is using the database heavy, then all these other services are now also experiencing a slowdown. So they're really not independent services from each other until those databases get separated the way that microservices should be.
Yeah, this is a good point that you bring up, because like it's a matter of like what you're more like tolerant to, right? Like, is it a single point of failure where one part of one big database server might be causing you pain because like everything is hosted together? But I mean, you could also argue like you're just spreading around multiple databases, each of which might have issues, and then if one node per se goes down, then other parts of your app are going to suffer.
Right. Yep. Yeah, so the beauty of a microservice is that if you do have a database outage or some other kind of an outage in your application, chances are it's probably just one component within one of the microservices, which means that that microservice is down, but the other ones are all still completely functional if they're written to be completely independent of each other. If they're not set up to be completely independent of each other, then there's a much higher probability that a single outage will take down all of your microservices, which is not what you want.
Yeah. And towards the end, once you're done with your set of 13, maybe you can give us some pointers on like what people are commonly using, because like in the chat room, people are talking about Amazon, and Oracle, and different types of tech. So maybe give us a rundown towards the end on like what you see people use most.
Yep, for sure. Yep, we'll definitely talk about that. So this is the other type, which is the data model being shared. So imagine this example here is of a hotel system with a reservation service, a maintenance service, a housekeeping service, maybe a couple others that we haven't named here. And they're all working on this single data model that is for a hotel room. This is kind of how you would do it if you're doing a monolith, right? You'd create a hotel room object, you'd create a hotel room table in your database. You'd put all of the fields, it would sort of normalize the data model and put all the fields that related directly to a hotel room would go onto the hotel room model. And then everything all around the application would share that hotel room model whenever it's, accessing stuff out of the hotel room table. So it's easy to kind of jump from that straight to making microservices and say, oh, I should probably do the same thing and do what I've always done basically and create a model for the hotel room and share that throughout my code. Now, imagine if you did that and in the housekeeping module, they said, the minutes to clean shouldn't be an int, it should be a float. It shouldn't be a float, it should be an int, because we don't really care about how many minutes and seconds it takes to clean a room. We just care about it at the minute level. So if it's 5 or 6 minutes, we care about that. We don't care if it's 5 minutes and 10 seconds to clean a room. So we're going to switch that over to be an int. Well, if maintenance and reservations were also using the hotel room, even if they don't care at all about the minutes to clean, which you wouldn't care about if you were, say, doing reservations, you don't care how long it takes to clean the room, just to make a new reservation for an available room. But by making that change, you've basically broken those other two microservices. So the proper way to do this in a microservice is to actually split all those properties out so that each service has a hotel room entity, or in this case, data model. And that entity or data model has just the properties that service cares about. Now you might ask, so for example, reservations cares about whether the room is occupied, how many beds are in it. Maintenance cares about the repair history events, and housekeeping just cares about how long it takes to clean. And, maybe there's another one in there for housekeeping that's like whether or not the room has been cleaned today or not, something like that. So you may be asking the obvious question, what if there's something, like the room number, for example, of the room that needs to be in all of these? What would you do with that? Well, you would have that copied between all of these services. There would be a room number in reservations, there'd be a room number in maintenance, and there'd be a room number in housekeeping, which feels really weird when you're used to creating monoliths and normalizing your database. Feels like, oh, I'm doing something wrong because that's copied so many places, but that's the correct way to do it in microservices. Problem number 3 is failing to separate subdomains. I'm not going to go into a lot of detail about this one because it goes pretty deep into domain-driven development. But for anyone who's not familiar with domain-driven development, it can be a very useful concept to learn more about if you want to try and figure out how to decide where to draw the lines between different microservices. Domain-driven development, or DDD, has this concept of domains, which is basically like the whole space that you do business in, the subdomains, which is like what ends up essentially being your different microservices. And then they also have this definition called a bounded context, which they say is the setting in which a word or a statement appears that determines its meaning, which sounds like total nonsense when you haven't done DDD before. So how do I think about it? I think basically if you think about, I want to create the lines between my microservices so that I have the smallest possible microservices without creating chatty communication between those services. Now, smallest possible and chatty are up to interpretation. So for sure, this is the type of thing where debate could be had in any specific situation. Should this be this in here, or should it be in there? Should this, service be separated out into its own service or not? All of those things are a bit of a debate, but you're essentially, in any of those debates, you're trying to balance keeping the microservices as small as possible without creating lots of unnecessary or extra communication between your services. All right, so the next mistake that I see that's really common is assuming that starting from scratch is going to be the best thing. Any of us that have been doing software development for a long time know everybody prefers a greenfield project. You don't have all of that legacy weight around your neck of all the bad decisions that have been made in the past, or poor architectures, or poor database designs, or whatever. So we call those brownfield projects, and greenfield projects. It just sounds better, right? But actually, there's a lot of advantages to taking a brownfield project and migrating it to a microservice. So some of the advantages are, for example, that you already have code that shows you the relationships between your different parts of your application. This can be really helpful to see after this application has existed for maybe months or years in a monolithic form. You can actually see in the code how one piece of code relates to another piece of code, or one module or endpoint relates to another module or endpoint. You can actually see the code references right in your code that tells you, oh, this and this are actually highly coupled to each other. Should they be? Shouldn't they be? There's a lot of information that you can get out of those existing relationships. You also have, typically, when there's a brownfield project, you'll have people around that helped build that project that you can talk to. Why did they make decisions the way they did? What would they do differently? What things ended up being less related to each other than they thought they were going to be when they started the system? Importantly, you also have a system that already works. This is really great because so many microservices projects fail completely that, at least you, in this case with the brownfield project, you have a system that you can kind of fall back on. So you're really just looking at making improvements or refactoring what you already have into a microservice. And then along those same lines, you have a baseline to compare as far as performance goes. So you can think about, moving your code a little bit at a time into a more of a microservices architecture. You can always go back and see what your performance is like and how it compares to what it used to be. Are you making things better? Are you making things worse? When you're doing a greenfield microservice project, you don't have anything to compare it to. So it's kind of like when you launch, you find out how the performance is for the application and whether you did it well or not. And you don't have that advantage of having the existing app as a baseline to compare it to.
Yeah. Jay, a quick pause here, question here, or maybe more of a comment. For Wilson was saying, I would imagine microservices that does a specific thing equals as small as possible as to like how we break things down. So like, does this to you sound a little bit like the single responsibility thing that we have always been, taught? Like, how small should it be?
Yeah. Yep. It is very similar to that, but I'll give you an example in a little bit. One of my mistakes is making your microservices too small, which I think will outline a pretty good example of what you don't want to do and why you're trying to balance that chattiness compared to the size. So whoever asked that question or brought up that topic, bring it up again if you don't feel like we address it enough when we get to that one.
Yeah, people have been thinking about solid principles while you've been talking. So
yeah.
All right, we'll let you go.
Solid is really great and super helpful for all software, but there's a few things about microservices where you have to basically you have to do the exact opposite of what you've learned for all these years.
Yeah.
So there's a bunch of different ways to get a brownfield project that's a monolith to a microservice. One of them is just keep working on it until you've got the whole thing done and launch it all at once, the big bang approach. Not recommended unless you have a pretty small project. This is the riskiest way to do it. Evolution, you could kind of think of this as like doing it in waves, where you basically refactor things and make it a little bit worse because you're trying to move it towards microservices, but that necessarily makes it a bit worse for a minute. And then you make some more changes after that to make it more performant microservices. And then you go, attack the next section of the app, make it a bit worse by trying to start separating things out. Eventually, you've refactored enough that it starts to get better again. That's kind of this evolution. And then the strangler fig is something that Martin Fowler actually identified. I think it was in New Zealand, where there's this vine that grows in a tree. It starts out in the tree's branches and it grows down into the ground, eventually sinking roots in around the tree's roots. Once it gets those roots in there, it starts to actually choke out the tree's roots and eventually kills the tree off. And now it's basically this dead backbone of a tree that is just basically holding the vine up and giving the vine's branches, extra access to sunlight. And so that's actually the approach I would typically recommend especially for a larger application. So you could kind of think of this like putting your application behind a facade. This could be an API gateway where you've got a larger chunk of legacy code, moving some stuff over into the modern or microservices side. Eventually you get more stuff over here into the microservices side. All the time you're kind of refactoring your facade layer, which is your API gateway probably, to keep things consistent. So for the front end application calling this, it looks the same all the time. And then eventually you've got everything moved over into your modern architecture and you can kind of get rid of the facade that you created. This is probably the best approach for migrating to microservices.
Chat room had a quick, more of a general question. Like, how do you measure, like, if what you're doing is being successful? Like, you talked about migration. Like, is it performance only? Is it, cleaner code base?
Yeah, there's a couple of things to think about when you do microservices. You're going to eventually have faster deployments, more deployments, and completely independent applications, which means high availability. Even when you're updating another module, none of the other modules go down because of that. So that's kind of the goals that you're going for. That's also going to allow you to scale in more specific ways than you can scale a monolith, which means that you will get some better performance. Like if you get to, if you're going from like 1,000 concurrent users to a couple of years later, you have millions of concurrent users. You're going to have to do something pretty significant to get your application to work well for millions of concurrent users compared to thousands. And the tricky part is that if you're going from thousands to tens of thousands, let's say, that the performance difference between going to microservices or not is probably not going to be that big. But that you can't do millions with your monolithic architecture without doing some pretty significant changes to it. So there's that like scalability performance side, but then there's also the throughput side, which is basically the how long does it take when someone does something in the application for every part of the application to know about that something having happened. Almost by definition, like a small scale monolith is going to be faster at that throughput of data than a microservice will ever be, because there's that disconnection that happens between the different services or modules of your application where data gets updated in one place and it has to replicate out to other places. So it's a bit of a tricky thing to actually measure the performance, is basically my point, because there's different ways to look at the performance, and because the performance that you are going for with microservices architecture is like plural orders of magnitude different than what you could do with the same monolithic architecture. So pretty difficult to actually compare those things, unfortunately.
Yeah, that makes sense. And I'm just watching our time here. Like both you and me are, and this is such great information. But like, let's give ourselves maybe another half an hour to wrap up. And I'm going to just mention one quick thing because Wilson was asking, is this getting recorded? So yes. So give us maybe a day or so, and then we put this up on YouTube so you can watch.
For sure. I'm going to skip this one just on interest of time. We've also already talked about some of this already. So Just a reminder, if people wanted to go to this bit.ly link, if there's any information that's interesting, useful, funny, whatever, if you want to go to this link, like I said, I should have written $100 there, but if you guys give 100, I'll match it tonight. Improper code sharing. What I kind of want to call out with this is if you're, is kind of what we were talking about before with the shared data model. If you are using a data model, even if it's 100% the same, the dry principle, the do not repeat, don't repeat yourself principle says, do not copy and paste code. Well, guess what? If you're doing a data model or a DTO, data transfer object, and you're using it with exactly the same properties in two different services, you should literally copy and paste that code between the services so that there's no actual relationship between those two things. Because if you try to create a class library that you reuse between the two, you're creating coupling between your services accidentally. This is the one I was alluding to earlier, microservices that are accidentally too small. So if you imagine somebody was getting kind of overzealous about splitting their microservices up, and they said, I'm going to have essentially one service per endpoint. So I'm going to have a login service, and I'm going to have a password reset service, and they're going to be totally separate from each other. Well, obviously, especially the password reset service is going to have to chat with the user login or the account service or whatever. They're going to have to talk to each other a lot to pass information back and forth to keep things in sync between each other. Anytime you see a lot of these arrows, hopefully they're arrows that are actually going down to an event bus, not directly like this. But even if they're going to an event bus, if you see lots and lots of communication happening between two services, or in fact, if you can't do anything in a service without having to update another same service, then there's pretty good chance that you've got high chattiness between those two services and that they should probably be combined. So that's that balance between chattiness and small services.
Jay, quick question here from the chat room. Maybe let me make sure I understand this. So King of God is asking, is there typically information lost when transforming your monolith into a microservice, like seeing as you're splitting objects into pieces amongst multiple databases? Do you have any thoughts? Or maybe King of God, you can explain, like, what do you mean by information lost? Jay, is this like database sharding in a way? But the sharding is done on different, vectors.
Right. Yeah, I mean, it kind of is. It's like instead of sharding on the row level, which is typically what you would do, you take a whole database row and say this row belongs to this customer, so it goes in this database, right? This is almost like sharding based off of the particular property and what part of the application cares about that property. And if multiple parts of the application care about that property, then you have to have multiple copies of that property. That is the thing that kind of breaks people's brains at first when they're used to building monoliths, is that's pretty different, and it does not follow the dry principle at all.
Yeah, makes sense.
Decentralized logging. I'll go kind of quickly through this one, but there's a tool. So this kind of blows people's minds too sometimes when they're first getting started with microservices. But when you have a shared component like logging, it creates a kind of coupling. It creates two different kinds of coupling actually between your different services. One of them is if you write an error into your logging module and you're sharing that logging module throughout all your services, well, eventually that error is going to now propagate to all of your different services. And you're potentially going to have, one situation that brings all of your services down because your logging class, had a vulnerability in it or something. The other kind of coupling that people maybe not even thinking about with microservices is that you actually tie every service to use a particular type of technology stack if you have a shared class library. So if you're doing .NET and you do a .NET class library or a .NET standard class library or something like that, well, that means that everyone that wants to use the logging for your application for all the different services within your application need to use .NET. because the dotnet logging library is the only choice. So the way you want to solve that is by getting a logging service that does two things. One of them is it has to provide a way to log in all the different major technology platforms. And number two, you want one that is very fault tolerant and works, sort of embraces the eventual consistency and fault tolerant model of microservices. So, of course, there are services like this that exist. One of the most popular is called Seek, which is SEQ. If you look at it, kind of serves a role as like this broker, and it also embraces the disconnected eventual consistency model where you can log stuff to Seek. And even if it's not currently connected to its data store, temporarily it can queue all that stuff up and eventually write it out to the data store when that becomes available again. So, and then Seek is available with libraries for all of the popular development platforms and languages. So you aren't tying all of your teams into a particular tech stack. You can say, oh, if you're a .NET team, you can use Seek. If you're a Java team, Python team, Go team, whatever, you can use Seek no matter what. So this is a good thing to think about when you're trying to figure out how to handle the cross-cutting concerns like logging in your application, is how can you make it fault tolerant, disconnected, and how can you make it not technology, or make it like technology agnostic, basically. Synchronous communications is another common mistake. Typically, this happens when you draw the arrows between one service layer and another. If your service layers are all API, like RESTful APIs, web APIs, it's pretty easy to say, oh, I need some data. I'm processing an order, but I don't have the customer information. So I'll just make a call. When someone hits the order endpoint, I'll just have the order endpoint make an API call out to the customer endpoint and get the customer data. What happens here is two things. If your customer's service and your order service are two separate services, what happens if your customer service in this situation is under heavy load and is in fact slowing down? Well, your order service is also going to slow down, even if it's not under heavy load, because every order has to sit there and wait while it calls the customer service. And if the customer service starts taking a longer time to respond, then the order service is going to start taking a longer time to respond. So through this remote call here, you've actually created a coupling. The other thing is not just performance, but what happens if the customer team is bringing the customer service down for maintenance or updating it and it's not available? You've just basically made your orders service also not available. So that's sequential calls are an important thing to avoid completely, because you don't want that to happen. So this brings us to kind of like a big like check-in moment here. When am I going to do microservices and when am I going to do monoliths? I'm going to do microservices when I want high availability, but I'm okay with eventual consistency. I'm okay with my data taking a little bit to propagate throughout all the parts of my application. If I'm trying to have an application that has immediate consistency, but it's okay if it goes down, on Tuesday nights at midnight every week for a release to be, have the entire monolithic application updated all at once, well, that's probably a better fit for a monolithic application. So shared test environments, I'll hit this one lightly just in the interest of time, but if you're mocking code, another thing that you would probably do pretty consistency with the dry principle is that you would create a single mock class for, let's say if you were mocking a customer's class or customer service, you'd create a single copy of that and you would reuse that throughout the entire application to do mocking of that service. But same thing with testing happens with other types of coupling. If you do that single service and share it, you've actually coupled those two components together. Even if they're in separate services, you don't want to do that. So again, it's going to feel really weird when you first do it. But if you're creating mocks in microservices, you may have a customer mock that you create that's in service number 1, and you might have another copy of it that works slightly differently that's in service number 2, and maybe another copy of it in service number 3. So something that feels a little bit unnatural, but is an important way to keep the services from being coupled to each other. Number 11 of 13 is not using automating CI/CD pipelines, basically, or automated versioning. If you're going to be doing microservices, you're probably going to be doing a lot of releases. In fact, rule of thumb is that you want to have a separate source repository for each service. You want to have a separate CI and CD pipeline for each service. So that's a lot of things to deploy. That's a lot of times that things need to get deployed. The whole benefit of microservices is this idea that you can quickly redeploy things or make updates to your application because of the low coupling. And if you don't automate your CI/CD, then you're kind of breaking that. Also, is going to be obviously prone to human error. And then the other thing to think about is that it's not uncommon for microservices to need to support multiple versions of themselves for backwards compatibility. Anytime you do a breaking change, that's not just the addition of new functionality or new endpoints, but is like changing something, you're going to have to version your endpoint. And so you're going to want to think about what tools you want to use to do versioning. And there's many ways to do that, but you don't want to do that like manually every time.
Yeah, and in the chat room, Fedor Wilson is saying Netlify, Heroku make things easier. Do you use any of this, or have you had experience or seen people use?
Yeah, yep. All of those things are pretty common to use when you're building microservices, for sure.
Yeah. Tooling helps. Surprise.
Yep. Yeah, and you don't want to reinvent the wheel on some of this stuff. If you find yourself creating your own event bus, you're probably making a mistake. This one is huge. Maybe I shouldn't have put this so far into the talk because it's so huge, but there's this law called Conway's law that says any organization that designs a system is going to produce a design whose structure is a copy of the organization's communication structure. Basically, it means that the thing that the team builds is going to be in the same shape as the team itself. An example that's commonly given for this, if you have 4 groups working on a compiler, you're going to end up with a 4-pass compiler. It's just kind of how it goes. So if you have a single team currently working on monoliths or a monolith or many monoliths, then if you basically say, okay, guys, we're going to all do microservices now, the whole team is going to just work on microservices, and like whatever comes up in the backlog for whatever microservice, whoever is available next from the team is going to pick that item up and work on it. Doesn't matter which microservice it is. Almost without fail, that team is going to start producing a monolith, or worse, because they're trying to do microservices, they're going to produce a distributed monolith. So what you want to do is not have a single team. If you have multiple services, you want to have multiple teams that are totally independent of each other, that focus on a different domain area, have different expertise, maybe different technology stacks even than each other. Now, this isn't 100% like hard and fast, right? You might have a situation where you have a couple of smaller services that don't necessitate an entire team. So you might have a team that shares a couple of smaller ones or something like that. But don't allow it to slip all the way back to where you end up basically with this or some version of this where basically everyone is working on everything. That's going to very naturally lead you to a distributed monolith.
So, Jay, quick question here. And I see the advantage, but I'm just going to pretend like I am, the one I'm the VP running a big, tech company, and I have a huge app with, a big team supporting it right now. And when you break things off like this, I love the fact that you have the independence to go, whatever be your technology stack that's best suited. But what about, as an enterprise, if you are a little resistant to, like too much of variety in your technology stack? One team is using .NET, one is all over Amazon. Like, is that like too much to manage as a company sometimes?
Yeah, this actually brings up a really good point. Microservices aren't great for small teams building small applications, really. And that is kind of that's one of the maybe in between the lines things that I've been saying tonight is that if you're building a medium-sized application that currently has no performance problems, but you hope someday that there'll be millions of people using it, but who knows? And you've got 3 or 5 people working on that or something currently, don't build a microservice. When it starts suddenly scaling, not linearly, but like overnight, you're having millions more people using it all of a sudden. That's when you start thinking about, okay, now it's time to start re-architecting this, not as a monolith. And in the meantime, you're going to have to throw some hardware. You're going to have to throw some load balancing. You're going to have to throw some data sharding, whatever else at the problem while you're, re-architecting. But it's a very common thing for us engineers to do to solve a problem that hasn't come up yet, and then never does come up, right?
Yeah. So I think Jay and me both know Steve Smith is a good friend of mine and yours, I think, out of Cleveland. And he's a big fan of what's called the pain-driven development. Like, don't refactor, don't do all of this unless it's causing you pain.
Yeah, that's a good way to say it. Yep, I like that. The last one I'll mention, and then we'll kind of get to our question time, is unencapsulated services. So this is basically services that have too much API surface area and compared to their implementation size. A well-designed service is going to work much better for microservices. And a well-designed service will have what's called a high water line. So if you imagine an iceberg, where the saying goes anyway, that 10% of the iceberg's above the water and 90% is below the water. That's a well-designed API as well. If you imagine that above the water is your API endpoints, your API surface area, your API like public definition essentially, and then below the water line is the implementation. A well-designed service is going to have lots of changes happening in its implementation, refactorings, performance improvements, maybe even technologies being swapped out for other technologies, maybe even, that strangler fig approach we talked about before, like the whole application's maybe getting rewritten under the waterline. You don't know any of that as a consumer of the API, but if you accidentally architect it with a large API surface area, then it's going to be very, very difficult to make it a good microservice because those API endpoints are going to have to be changing all the time, anytime implementation is changing. And we don't really want this line here. We don't want the team to have to be making changes to the public API definition very often. That should be pretty stable for a well-designed microservice. So to sum everything up, if you're looking for a lightweight application for a single team, then a monolith might suit your team better or suit your application better. If you're looking for something that's more complex, that is going to evolve with clear domains between the different parts of the application, maybe with a larger team that can focus on where different parts of the team could focus on different parts of the application, and eventual consistency is okay with you, then maybe microservices are a good fit. And certainly don't just try microservices because you've heard the buzzword. If you don't have, as Sam Newman says, a really good reason, because monoliths can be good too. And if you do end up building microservices, be careful with coupling that we talked about. 13 essentially different kinds of coupling in all of these examples I've given you, and avoid those pitfalls that are going to lead you down the path to a distributed monolith. A few books I'd recommend if you want to read more about this. A couple of O'Reilly books here, and then another, I never know how to say this. Do you say it Pact?
Yeah, I think Pact.
Okay. Another Pact book. These are great starting points for architectures and about microservices. A couple of other resources I think are interesting. Nginx actually has a microservices ebook, and then there's this other one that focuses more on the database side of things when it comes to microservices and other modern architectures. Martin Fowler's.
Yeah. No, Jay, if you go back to the databases thing, because we have a question, and this is so on point. One thing I think, Jay, we have to be conscious, especially as we age in this industry, is not everybody speaks the same language. I was doing a talk on the different ways to build desktop applications, and a lot of folks who are just coming out of college, or maybe you've had a change of career and you're coming in, you just don't have the history, don't have the baggage that we often carry. So we have to kind of break things down. So on that front, and especially since you have the databases thing up, King of God is asking, I'm relatively new to software engineering. What exactly is data sharding? And I don't think I know enough to answer this very clearly. So how would you define data sharding?
I would define data sharding from a practical perspective as basically picking a key in your data. Typically, it's going to be something like a tenant ID, if you've heard of the concept of multi-tenant software, or a tenant might be something like the user ID or the customer ID or something like that, where all of the data that is associated with a particular value of that key could be stored in a separate database, and there would be really no downside. So there's a lot of services you've probably used on the internet that basically do this behind the scenes, where every time a new company typically signs up to use one of these services, they'll create a new subdomain, or behind the scenes, what they actually do is they create a new database for that customer, because that customer is going to have their whole own database. But when you go to that subdomain, that's like, your company name .someservice.com, it's creating basically a completely separate copy of the application for you, and a completely separate copy of the database for you. And then when you log in, it basically says, oh, I know who this user is, and they're part of this organization, so I'm going to redirect them to behind the scenes to the database that all of that data is in. That's essentially data sharding, is saying we can identify a key on all of this data that essentially attributes an owner to this data, and we can separate the data out into different physical data stores based off of that key.
Yeah, no, that's well said. I mean, think about how a traditional database has been, like the orders and customers thing that Jay mentioned. Like if Amazon had one orders table and one customer table in a single database, we would not be using the internet at all, right? So it just does not scale unless you shard per customer, per location, and then you have ways of bringing it all together, running a query if you needed to, but it's all separated out logically and maybe even geographically.
Yeah, totally.
Yeah. And so Footer Wilson is saying, I'm new as well, currently transitioning from the military. Well, thank you for your service. And I'm a participant in Microsoft Software and Systems Academy for Cloud Application Development. Wow. Did you know this? Microsoft did this? Because I didn't know that. So they have multiple academies.
Yeah, there's a lot of cool online resources. Actually, one of the links right here on this page is this architectural guidance one at the very bottom of my list.
Yeah, I've seen that cloud native, and yeah, the overall, and they don't do it just for microservices. They also have it for like mobile apps and desktop apps and other things.
Yep.
It's pretty good.
Yep. And this eShop is a nice reference app that's been built several times with different technologies, and this one that's quote unquote cloud native is like a containerized one, a Docker containerized one that has a lot of architectures in it that are microservice friendly. So that's another one. It's the second from the bottom one. I recommend checking out if you're like a C# developer, .NET developer, and you want to see a practical example of something someone's done that is a true microservices implementation.
Yeah. All right. A few more questions here, Jay, from the chat room. Did you have more things you wanted to show?
I'll just mention this link again. I haven't had a chance to check the link while I was talking, but hopefully people found this okay, and hopefully you guys liked the talk enough that it's going to cost me $100 tonight.
I might take you up on that offer after we're done here.
Yeah, so then I'm open for questions for the last few minutes here, and also just wanted to mention this link to GitHub at the bottom of this slide has all these slides available if you want to check them out later and view it again. So
very nice. Okay, so chat room, Anurag Kalra is asking, if a client is expecting a response for their request, like updating user data, how will that work if the client is making a synchronous REST call and then multiple microservices are processing the request and updating different databases? How will the client get a response? Do you understand the question?
I do understand the question. So let's talk through a specific example because it might be more helpful to think about it this way. Imagine you have an e-commerce system, because everyone's kind of familiar with, like, an Amazon type of an e-commerce model. It's going to have probably like an account service where you can go change information about your account. You can add, shipping address, payment methods, those types of things. And that's probably going to have another service that's like a shopping cart, and then another one that's actually processing an order. So the cart is going to basically create an order, and the order is then going to process through, and you can go back into your see my past orders part of the application and see all the orders and where they're at, the status, the tracking information, etc. So in that scenario, if a user goes in and changes their default shipping address, that's going to be through the account service. And that data probably needs to be in at least two places in the application. One of them is in the account service, obviously, because that's where you're making the change. And when you go to your account, you want to be able to pull up what your current shipping address is and display it to the user. But the minute that somebody changes that shipping address, they might also be in the middle of creating an order. And if they go ahead and process that order, we want to use the new shipping address. And so because of that, you want to probably publish an event to your event bus that says, here's a shipping address change for customer 123. And the orders service will probably say, oh, I care about that. I subscribe to shipping address changes because as the order service, I'm concerned with where to ship these things to, obviously. And so it would basically receive that event and say, I need to go ahead and update this customer's 123's address. So I'll read this event and I'll, asynchronously or in a disconnected way, update that as soon as it gets time to process that event. It's feasible that if your system is under very, very heavy load, that someone would go change their address and then immediately go click the, have a whole order ready in their cart and then go click the checkout button. And that address would not have propagated yet to the order service. So
don't try this.
So there's ways to kind of solve that. But what I want to kind of show you with that example is that is intrinsic to how microservices work. That you have to be at least somewhat okay with that possibility if you want to do microservices. That is an example, a very concrete example of what's called eventual consistency. Eventually, the whole application will be consistent with that shipping address, but there might be a short amount of time where there's two different shipping addresses, one in the order system that hasn't updated yet and one in the account system that has. So if you really don't like that and that's really not going to work, like if you're doing a bank transaction processing module or something like that, maybe eventual consistency is not for you.
Mm-hmm. Yeah, well said. Now, I think you kind of allured towards this, but Anurag is also asking, you mentioned that it's a bad pattern if services are calling each other all over the place and it's chatty. But if you want to avoid that, does that mean we need to replicate the logic and the data between services? Like how much of the logic do you see replicated? Hopefully not a whole lot, right?
Yeah, not a whole lot, but some. If you imagine that you might have like an email address validation logic or something like that, if you have completely separate services that are from completely separate code repositories, maybe even built on different tech stacks from each other, you're probably going to have an email validation logic that is, different for each service or is slightly different for each service. And that's actually, in this case, for microservices, a good thing. Normally, we don't like that, right? If you're doing a monolith and you have 5 copies of your email validation service, well, you're doing it wrong, right? That's repeating yourself in a way you don't want to. For microservices, that is the trade-off. To get that complete decoupling of the services, you have to completely decouple them all the way through, including, copying code.
Yeah, well said. Chat room, you've been so good. And King of God is talking about processing events on website and handling all those requests off of probably a bus, and this is being done by someone who's new to coding, like 3 months in. So hats off to you that you are doing stuff like this.
Yeah,
hats off. Good stuff.
It's pretty advanced. Yeah.
All right. So this has been amazing, Jay. You're an awesome speaker, as I have known for years. But let me ask you one last thing here. Like, in your experience of doing this, give us like a good or bad. Like, give us like without maybe taking names, like a really good implementation of microservices architecture, or something that makes you pull your hair apart.
One great example that we all deal with, at least as a user at the user level, is Amazon's e-commerce website. I read an article not too long ago that they do tens of thousands, if I remember correctly, of deployments of new features a day, or fixes and features a day. And that's not for all the AWS stuff that they maintain as well. That's just talking about the Amazon.com, basically. Maybe that includes things like Audible and some of the other websites that they own that are essentially e-commerce. But, think about that, like such a huge, complicated application. How often do you run into errors on Amazon.com? Not very often. Maybe 1 or 2 times I can think of clicking on a link on Amazon and ending up on an error page. But that's after, unfortunately, probably thousands of hours spent on Amazon. And they're able to do tens of thousands of updates every day. And it's because they've written this as very much a microservice, or microservices, I should say. So every little part of Amazon.com that they could split up into different microservices they have. And so it's very highly maintainable, extremely high uptime, right? If Amazon.com goes down for 5 minutes, they lose millions of dollars. So, and so do a lot of other people that are selling on there. So, it's high availability, and yet can be updated 10,000 plus times a day. So pretty impressive. And then I won't give any negative examples, because I think we've all seen those in our personal experience.
Yeah, maybe even made some of those ourselves.
Exactly.
Chat room was asking Netflix. I don't know if Netflix. I mean, theirs is a very different type of problem. If they use microservices or not. I
think they do use microservices. I think I've read about that. Obviously, the video streaming stuff is like a whole separate problem. But for their like account management and the service that lists what movies you might be interested in and shows you the pictures of the like title cards or whatever, that's probably all microservices.
Yeah. And there's Wilson is saying they're pretty open about their documentation. And we actually know a couple of software folks who work on the Netflix teams. They'll come and speak at conferences. It's definitely worth a look. In some of these giants to see how they are dealing with some of the problems. They have a monkey army. They do. I think Jay, this comment here pretty much sums up. This is helpful stuff. Wilson is saying this hour and a half answered most of my questions I had today. So this is really good stuff coming from someone who's done it, for years and years. The experience shows in the way you talk about, the pitfalls and the good and the bad. There is no one thing, one, way of doing things. So, choose what is right for you.
Totally. Have a good reason, like Sam Newman says.
Have a good reason. That is the one thing to take away. Have a good reason. All right, so look at this. I mean, on a topic like this with a exceptionally good speaker, we burned through an hour and a half just like that. So, Jay, I cannot thank you enough for taking the time away from your work and your family, and hanging out with me and just teaching us stuff. We appreciate you a lot.
Well, thanks for hosting it, Sam. It was a lot of fun. Thanks for watching, everybody. Appreciate the questions and interaction.
Yeah, absolutely. And chat room, we appreciate all the questions. Let's see what else. Yeah, a lot of folks are here at Code It Live. If you're new, welcome. Yeah, we do a lot of different things on this channel. We do a lot of React, we do Angular, we do, and then there are the older guys like Ed Charbonnet, who's a good friend of mine. Ed and me are come from a heavy .NET background, so there's a bit of everything. We do a lot of light-hearted social stuff as well, because like life is short. We can't take ourselves like too seriously. So we are glad to see you here. Hope you come back, and if you are in the Americas, hope you have a great rest of your evening and great rest of your day. Thank you all, and thank you, Jay. And we'll see you around for the user group meeting. Third Monday evenings every month right here. So we'll see you for July. And take it easy. Stay safe, be productive, be happy, and we'll see you around.